Hi everyone and welcome back to PrepFusion. So today we will start with the assignment 2 solutions. So this was the first homework question. We have been given a current and voltage across a circuit I of t and V of t. So we have to determine the power factor. So what is power factor? Power factor is the angle between the voltage and current. So they haven't given you any circuit, they have just given you the voltage and current. So basically, of course, they are asking the power factor of this voltage and current. It is for the same element only. I don't know what is, like, is it input power factor or the load power factor, I don't know. But if they have just given me these two information, I will go only with this two values. But before starting the lecture, just wanted to clear one thing. I have made a mistake in the previous lecture where I told you that your power factor angle is same as the theta z, the impedance angle. No, it is not correct actually. I made a slight error there. Impedance angle is the angle difference between the voltage theta v and theta I, and this will make a huge difference later on as we move along in the course. And your power factor angle phi is the angle difference between theta I and theta v. There is a huge difference between these two things. Okay, so power factor angle is the difference between theta I and theta v. Impedance angle is the difference between theta v upon theta I. How can I prove it? So what is your impedance? Impedance is v upon I, right? So you can write magnitude of v divided by magnitude of I, angle of theta v divided by angle of theta I. So ultimately, right, overall value comes out to be magnitude of v by I, angle of theta v minus theta I. Okay, so that's why the impedance angle is theta v minus theta I, but the power factor angle, it is defined. Power factor angle is well defined. It is defined the angle difference between the current and voltage. So in the previous lecture, somewhere, right, I had written both of them are equal. They are not equal. Okay, so just magnitude wise they are equal. Magnitude wise they are equal because if you take the absolute value of theta z and phi, they will come out to be same only. Absolute value comes out to be same, like 30 minus 60 or 60 minus 30. Absolute value is same only, right? So, but the sign makes a huge difference, which we will learn later on as we move along the course. Although I have not explained about power factor much, power factor will come later on. So we have to find out the power factor here. So what is my power factor? Because nothing is mentioned here, no source and all those things, just a current and voltage is given. That means they are asking about the power factor between this current and voltage. That's it. So I know the definition of the power factor angle phi. Power factor angle phi is basically theta I minus theta v. So theta I, right, is the reference. From the reference, how much is it leading? 15 degrees. What about theta v? Theta v from the reference, how much is it leading? 60 degrees. So of course voltage is leading more. Voltage is lagging more. That is, current is lagging. Current is lagging voltage. That's why the angle is lower, right? In current, current is lagging voltage. And if current lags voltage, that means what kind of circuit it is? It is a lagging circuit. It is a lagging circuit. It is a inductive. Overall, it will behave as a inductive circuit. So power factor will be cos of 45 minus 45 basically, and cos of minus 45 is what? Always whenever you are writing power factor, right, for EC students not that important, but whenever you are writing a power factor, you must, like, this is cos of minus 47 will be 0.707, and in brackets you have to write this is a lagging circuit. This information you have to provide because the information about the negative sign goes away, right, after I solve this. So just be careful regarding that. Okay, just be careful regarding that and keep this in mind. Okay, now let's move on to the next question. Next question was this one, where we have to find the expression for v of t and I of t. Not that difficult. So vs of t is given, right? So I have to find the expression for v of t and I of t. There are multiple ways which you can do. Okay, first way is using basic phasor. So what will be your I, right? In frequency domain it will be vs upon the impedance seen from here, correct? Impedance z. So vs is what? If I assume my reference to be sine omega t, so I will not write it now. Okay, this from now onwards I may not write the reference. You have to understand what is the reference. So if I assume sine omega t to be reference, the vs will be 20 angle 30, and what is your z? Z will be r plus jxl, correct? R plus j omega l. That is the impedance, right, of a series RL circuit. So this will come out to be 20 angle 30, and this is r is 4 plus j will be j. Omega, what is omega? Omega is here, right, 10. So this is omega, that is 10 into l. L is 0.2. Okay. Now of course this is in the rectangular format. I will convert this in the polar format for division, for making the division easier. So this is 20 angle 30 divided by 2, 2 plus 1. Okay, so this right will come out to be 20 divided 2 is there, so it is under root 5 root 5 into 10, 4.472, and this is tan inverse 26.56 degrees. Okay, this is the current. This is the current basically in phasor format. This is the current. You can find this out on like your rectangular format as well. Okay, so now can I convert this back into sinusoid, because I want to write everything in terms of sinusoid, correct? Okay, this is 26.856. This is not the current, actually this is the angle of this, right? 26.56. I have to subtract with 30, so I forgot to subtract with 30. This will be 3.44. 3.44, sorry, this is 30. I will keep this. So basically this will be 30 degrees minus 26.56 basically. So this, right, if I convert back into sinusoid, my reference was Vm sin omega t, so this will be sine of omega is 10 t plus 3.44 degrees. This will be an answer for the current. What about the voltage? Now if I know the current, right, finding out voltage is very easy. Like there are two ways to find the voltage. One is this simple equation that your VL, right, current is known, right, it is a series circuit, so VL will be LIL by dt. VL, that is your V, will be LIL by dt. This is the one way of doing it. So this will be because L is how much? L is 0.2, so it will be 0.2 into 10 into 4.472 sine 10t, not sine, sorry, cos 10t, because I am differentiating, plus 3.44 degree amperes. So this will be VL, or V will be equals to 944 cos 10t plus 3.44. Okay, not amperes, sorry, this will be volts. This is one way to do this. Other way is, was the method 1. Method 2 is you directly use the equation. What is your like VL? VL, if you remember, or V is equals to j omega L into I. So I is a phasor. Like either you do with phasor or you do in the time domain approach. So phasor approach is this one, that my I is here, right, in the phasor. So I can replace, like this will be J only. J can be replaced with 1 angle 90, correct? Omega can be replaced with 10. L can be replaced with 0.2, and I is 4.472 angle of, I think it is 3.44. Now is this the same as this one only? Is this the same as this one only? Yes, because I'm adding 90, so this, right, sine will become cos. This 10 into 0.2 was already here, 10 into 0.2 was already here, this was already here. It's the same, there is no change, right? Same thing only. So ultimately your V from here as well will come out to be, this will come out to be, the magnitude will be 8.944 angle 93.44 degrees. Now if you convert this back into sinusoid, this will be 944 cos 10t plus cos 10t plus 3.44 degrees. This will be your voltage. Okay, so yeah, that's the thing basically. Let's solve the next question that I gave you as homeworks. So I don't feel like these are very draining questions, these are simple questions only, right? So if I see this question, if the voltage V is equals to 25 sine 100t minus 15 and is applied across a 50 microfarad capacitor, calculate the current through the capacitor. So this is like either you can do the phasor approach or using the time domain approach. So let's first do the time domain approach, that is very easy. Basically, right, you know method 1, the time domain approach, because it is just a single capacitor. If it was a resistor and a capacitor, then things would have been a bit difficult. So method 1 is simple time domain approach. So I know IC of t is equals to C dVc by dt. C is 50 microfarad, dVc by dt, that is 25 into 100 into cos 103 minus 15. Okay, so this value, like it's like a one liner question, but if you want to do with phasor, we can do with phasor as well. I will show you how we can do it with phasor. So this will be 5 125 1250 10 to the minus 6 10 to the power minus 4 cos 100t minus 15, or this one will come out to be 1.25 not okay, let me just use, okay, if I use all, yeah, this will be 0.125 cos 100t minus 15 degrees. Okay, this can be the answer, or like of course other one will be same only, but you can use the phasor approach. So with the phasor approach, what do you do? I know that my, how is my VC and IC related? I know my IC, if you remember, it was equals to j omega c VC, because here the current was leading. Previously the voltage was leading for inductor, here the current will lead for the capacitor. So I know what is my omega. Omega is 100, right? Omega is the frequency of the sinusoid. Frequency of the sinusoid is 100 radians per second, and C is given as 25 microfarad, or 25 into 10 raised to power minus 6. Okay, yeah, that is or not, I think C is 50, right? Okay, C is 50, C is 50, C is 50. C is 50. So just hold on. So what I can say, what is VC? VC, right? As my sign is in sin omega t is reference, so this VC will be 25 angle of minus 15. 25 angle of minus 15. So your IC, all the quantities are known now. All the quantities are known. This J can be replaced with 1 angle 90. Omega is 100. C is 50 into 10 raised to the minus 6. VC is 25 angle minus 15. So ultimately, right, what it comes out is again the same multiplication only. This overall quantity comes out to be 0.125 angle 75 degrees. And if you just convert this back into like sine, either you can write this as 0.125 sine 100t plus 75, or you can write this in terms of cos as well. So this will be 0.125 cos 100t minus 15 degrees. Okay, so both way works, whichever is suitable to you. So this was the next question. So this is a very good question. Now this is not that simple of a question. Okay, now like ऐसे ही हो जाएगा, just differentiate कर दिया time domain. No, for this question you have to think. Like first thing that should come into your mind is that, can I do some algebraic sum here? No, you cannot do the algebraic sum. Okay, because should have mentioned here, even if it's not mentioned. So all the values given here are magnitudes. Values given are magnitudes because they have not provided any phase. Of course, you have to assume it as magnitude. So that was the first catch. I don't think you were able to catch it. So there are multiple ways to solve this question. So first way is using phasor diagram. Okay, so using phasor diagram, how will I solve? So this is like a parallel RLC circuit, which we will study in the next lecture. But still, without knowing that concept also you can solve. Okay, so I told you one point. I told you in AC circuits is that if no reference is given, you choose a reference and from there you solve. In this case, what reference shall I choose? Should I choose current as a reference, or if I am measuring a voltage across all the element as B because they are in parallel, should I choose a voltage as reference? I should definitely choose a voltage as reference. So my voltage will be reference signal. Okay. Now if voltage is reference, right, then the current through this resistor will also be in the same phase as the voltage across the resistor. So this 2I0 is actually in the same phase as the voltage. 2I0 is actually in the same phase as voltage. What about the current across the inductor? So this is the magnitude, right? So the current across the inductor, I know, lags the voltage across it. So it should lag the voltage. Okay. This I0 should not be, sorry. This I0 was not given, sorry. This I0 was just for some, this is I0, this is just IL, okay? IL. Just IL. So because this IL was not given to us, they have just asked this relationship, right? If LC is K, then magnitude of K will be what? Absolute value of K will be what? So IL, I don't know what is the magnitude of IL, but this much I know that definitely IL will lag. And VC, capacitor current, right? Capacitor current leads the voltage. Voltage is V, so capacitor current will be somewhat here. Now overall, what will be the behavior of the circuit? Overall, will it be inductive or capacitive? For this, you have to take cases. Okay, you have to take cases, and after taking the cases, we will understand without taking any cases how we can solve this. Okay, just with intuition. So let's first take few cases. Let's assume like this IL is here, right? IL is here in the downward direction because it will lag. IL will lag. Correct. This is my IL, and this is my IC. And let's assume in the case 1 where my IC is less than IL, correct, and IC magnitude is given as 0.5 I0. So if IC is less than IL, let's assume a number. Okay, let's first assume the wrong case. Basically, let's first assume the wrong case because I know you have known the correct case. So the wrong case is basically my IC is greater than IL. Why is the wrong case? We will understand. So let us take that. So if IC is greater than IL, that means I can assume any number to IL, right? Let's assume a number as 0.25 I0. Okay. Now if I find out the resultant, because ultimately, right, KCL will not be violated. That is, your input IN will be phasor sum of IR plus IL plus IC. This KCL will never be violated. this KCL will always work. So the resultant of all of these three vectors should give me, the magnitude should give me 3 I naught, right? Magnitude should give me 3 I naught. So if this is the case, what is the magnitude? Magnitude will be basically, these will cancel, like this is opposing this one IC. So ultimately the resultant here will be value of 0.25 I naught, because IC is greater, so somewhat I will go above the voltage. So the resultant will be something like this, the resultant of these two vectors. So resultant of these two vectors are what? 2 I naught whole square. I'm just talking about the magnitude 25, I'm not concerned about the angle, under root, this is the magnitude. So if I find this out, what am I getting? 2 in 2 square plus 0.25 whole square, okay, under root. So it is coming something lower, 2.01, okay, it is coming something lower, and it will always come something lower. Minimum, like I am choosing something lower, right? Minimum where IL can go, you can choose IL equal to 0. If you choose IL equal to 0, then this value will be maximum, then this value will be maximum. So let's choose IL equal to 0. Let's choose IL equal to 0. So I have chosen something less than I naught, and it is not satisfying. What am I expecting? I am expecting here 3, right? 3 I naught. I am expecting here as 3 I naught. Why am I expecting 3 I naught? Because ultimately, right, this KCL should validate. So hence the addition of these three vectors, the magnitude should come out to be 3 I naught. But here I am only getting 2.01 I naught. That is not possible. Let me choose the minimum value of IL so that this increases, because I need to increase this so that the magnitude increases to 3. So how can I increase? By choosing the minimum lowest value of IL, that is 0. I can choose IL to be 0. So if I choose IL to be 0, then what does my magnitude become of the resultant? It will be, this will be fixed 2 I naught whole square, plus this will be 0.5 minus 0 I naught, so it will be 0.5 I naught whole square. So this comes out to be 2.061 I naught. So whatever you do, if you ever choose a lower value of I naught than IC, you will never be able to reach your resultant, because you have to satisfy the this equation, right? So you will never be able to reach your resultant. So of course your circuit, to satisfy this particular KCL, it has to behave as an inductive circuit. It has to behave as an inductive circuit. It cannot behave as a capacitive circuit. Okay, so that's why the phasor diagram here will be something like this. That your IL, inductive current will always be greater than the capacitive current. Inductive current will always be greater than the capacitive current. Okay, so now it will be something less, something greater than, right? I don't know how much it will be, but it will be something greater than that. So let me choose for now IL only. Let me keep it IL only. Let me keep it IL only. So, or let me do one thing. It will be some K times, or not K, sorry, M times I naught, because everything is a multiple of I naught. So it will be easier for us to calculate. It will also come out to be a multiple of I naught only. So now if I write the resultant magnitude of I, right, it will be IR whole square. IR whole square is 2 I naught whole square plus IC is 0.5 I naught minus M I naught whole square. This has to be equals to 3 I naught, no matter what. Magnitude must satisfy, because KCL must satisfy. So I can say that if I square both sides, this will be 9 I naught whole square equals to 4 I naught square, plus I can take the I naught square as common. Now I naught will obviously be a number greater than 0. I naught cannot be 0, then circuit will not validate. This will be 0.5 minus M whole square. Okay, so I naught can cancel out. So this will come out to be 5 equals to 0.5 minus M whole square, or I can write here 5 under root. So this will be plus minus 2.236 0.5 minus M. So now this is plus minus, right? So M has to be something positive, because M is a magnitude. M has to be something positive, right? So of course I will ignore the positive sign here, because if I take the positive, if I take it on the right hand side, it will give me some negative value m. That is not possible, so I will ignore the positive, I will take the negative sign. So if I take the negative sign, it will be added with 0.5. So basically, okay, not this, minus 5 plus 0.5, 2.73. okay, so your m comes out to be 2.73. your m 736. okay, so ultimately your current IL is m equals to 2.736 I naught. But have they asked this in the question? No. What have they asked? They have asked something else. They have asked if K is equals to LC, then find the magnitude of it. Okay. So one thing I know is that current across the inductor, magnitude of the current across the inductor is also equals to the voltage divided by its capacity, inductive reactance, magnitude of inductive reactance, that is j omega L. So V will, I don't know, V is some unknown value, but omega I know. Do I know? Omega do I know? Omega also I don't know. Omega they have not given, but L I know, right? What is L? L is just unknown value. Okay, I don't know anything. Okay, so omega L I don't know, but this is equals to what? This much I know, that this is equals to 2.736 I naught. Also, one more thing, the capacitive current. Capacitive current is again V by its capacitive reactance. Its capacitive reactance is 1 by j omega c, correct? So this will come out to be omega c V, because j, magnitude of j is 1 only, is equals to what? The magnitude of capacitive current is given as 0.5 I naught. Magnitude of capacitive current is given as 0.5 I naught. So this will be 0.5 0.5 I naught. Okay. Now if I take the ratio of these two, then I naught will be cancelled. L and C will come in product. Omega. Okay, omega will not be. No. I should not take the ratio of these two. Yes, I should actually take the ratio of these two only. Omega square will still be there, right? Oh, okay. Some mistake has been done on my behalf. Okay, if I take the ratio of these two, right? I have done a bit of mistake here, because I cancelled the omega. Omega was given, right? I think. Oh, sorry. Omega was given here. Sorry, I missed the part. Omega is given, right? Omega is 2 radian per second. Okay, so omega is given. So now if I take the ratio of the, like, if I write this, right, this will be what? This will be simply equals to V by 2L, and this will be simply equals to 2CV. Now if I take the ratio, what will happen? VV will get cancelled, so it will be C 2CV. Let's take the ratio of 2CV divided by V by 2L. Here it will be 0.5 I naught divided by 2.736. So this will come out to be LC. LC will be equals to, this is 4 will go there, so this is 8, so into 8, very low value, LC is equals to 0.0457. okay, this is your LC value. So this was the answer basically. So your K, right, K is equals to, K is a numerical value, K is a numerical value, that is 0.0457. this is your answer. Okay, this was a good question. Of course, I just made like I just did a trick that I did not mention that these are magnitude, but you should understand, I told you in the previous lecture as well, whenever we are solving an AC circuit, first question you should ask is, what is the phase difference? What is the phase difference, sir? What is the phase difference? Okay, that is the first question that you should ask. Okay, so yeah, that is about it. So let's solve this next question. Next question is also pretty good, because here, right, I am not asking you any phasor quantity, I am asking you instantaneous value. I am asking you the instantaneous value. Okay, so what is Vs of t? So Vs of t will not be the simple addition of these three, right? Simple addition of these two, because they have given you this is peak values, this is 15 volt, this is 16 volt, and they have given you this as reference, because they have given you phase here, the voltage they have given us phase here. Okay, so this is my VL of T. So what you should be careful is, should you choose their reference? Should you choose their reference? That is a question. So let's first choose their reference. Let's first choose their reference. What is the reference? Reference is 2t plus 30. 2t plus 30. Let's choose VL as reference only. So if VL is reference, because angle they have given only for VL, for none of the other quantities they have just mentioned the peak values. So VL is reference, correct? VL is the reference. So if VL is reference, what will be the current across the inductor? Current across the inductor will lag by 90 degrees. Current across the inductor will lag by 90 degrees. So current will be somewhere here. Okay. So current across the inductor will lag by 90 degrees. Now what is this current? This current is same as all of this current, right? Because this is a series circuit. So I also will be same here, correct? So now I know the current. So voltage also will be in the same phase. What voltage? This voltage will be in the same phase as the current only, because for resistive circuit voltage will be in the same phase. So this is my VR. It will be in the same phase as the current. What about this voltage? Now this voltage will lag the current by 90 degrees, because we know capacitor current leads the voltage by 90 degrees. So it will lag. So basically this voltage will be here. Okay. VC, it will lag, right? Lag means clockwise direction. So that's why we took so much time in the basics, because I will not explain every single thing here. All those have been explained. Why it is lagging, why am I moving in the clockwise direction from the current. So I will directly solve the questions now, because I want you to reach to the highest level. And these questions, right, the last two questions are actually future. I'm expecting GATE to ask these type of questions, because these have never been asked and you will never find this anywhere. These type of questions you will not find anywhere else. Okay, so voltage will basically lag the current. For capacitor, what have they asked? They have asked Vs. So what will be Vs? Vs will be combination. Vs is what? Vs is basically, Vs is the phasor sum of VR plus Vc plus VL, correct? And of course Vc and VL are both in opposite phase, so ultimately it will be a phasor sum of these two. Okay, so what I observe is peak value of Vc is 16 and peak value of VL is 10. So of course Vc will have higher length or size, so Vc will be high. So I can assume Vc to be here and VL to be a bit lower, so VL will be here. So ultimately, right, it will behave as a capacitive circuit. Ultimately it will behave as a capacitive circuit, that's it. It will not behave as a inductive circuit. So this is a, like, what is, if this is 0 degree, right? So what is VL? VL is assumed in phasor to be 10 angle 0. Okay, now don't assume it to be 10 angle 30. No. VL is reference, because they have given me angle and I choose the reference. I will do something else as well. In the method 2, I will not choose this reference, I will choose my reference. I will choose my own reference. Okay, so this is 10 angle 0 degree. IL I don't know. So magnitude for IL I don't know. VR magnitude they are then given me 15. But what is the angle? It is lagging from VL 90 degrees, so it will be minus 90 degrees. What about VC? VC will be, it is magnitude is 16, it is minus 180 degrees. Okay, VC magnitude is 16 minus 180 degrees. So ultimately, right, you have to do the phasor sum. This is equals to 15 angle minus 90 plus 10 angle 0 plus 16 angle minus 180. So ultimately what it comes out to be is 15 minus J15 plus 10 minus 16 basically. So this comes out, your Vs will come out to be, like if I just compute this value, this will be minus 6, so not, yeah, minus 6 minus J15 whole square plus 15 whole square under root. So this will be 16.156 angle. What will be the angle? Angle, right? This is in the which quadrant? Negative, negative. This is in the third quadrant. Third quadrant. And what is the angle at third quadrant? The angle at third quadrant is 180 plus theta. So I am not explaining what is theta, what is, how am I getting 180 plus theta, because all those have been explained in the first lecture. So what is theta? Theta is tan inverse mod of x upon mod of y. So it will be 15 upon 6. So 15 upon 6 is 2.5, tan inverse this is 68.2 degrees, but it is 180 plus this, so 180 plus theta comes out to be 248. You can write this. I don't like this large large angle, so I will just subtract 360. It does not matter if you subtract or add 360, it does not literally matter. So this value will come out to be equals to 16.156 minus 111.8. Now this is in the phasor format, but I want to be in the sinusoidal format. So if you want to be in the sinusoidal format, what you have to do is, what was your reference? Reference was this, right? Reference was this. So this is minus 111. I have to add plus 30 with the angle, and frequency will be 2. Okay, so this will be 16.156. I have to add 30 with it, so it will be 81 sine 10t. It was 10t, right? Sorry, sine 2t sine 2t minus 81.8 degrees. Okay, so this is my voltage basically. This is my voltage. Okay, so is there any other way to do? So we will see the other way. What is the other way? Other way is, you don't take the reference. They have given you the reference. No, you say I want my freedom. Okay, my life, my rules. So what you will do is, this was the method 1 according to their own reference. Now if I choose the method 2, method 2 is where I choose my reference. So I know this is a series RLC circuit, so current will be the best reference to choose. So current I will choose as I angle 0 as a reference. It is some Im sin omega t. Okay, it is some Im sin omega t. This is my reference. So my current is here. This is my current. Now of course the voltage will also be in the same phase as the current. Voltage across the resistor I am talking about. So voltage across the resistor will be in the same phase as the current. What about the capacitor voltage? What about the capacitor voltage? Capacitor voltage of course will lead the current, because current lags the, not the capacitor, sorry. What about the inductive voltage? Inductive voltage of course will lead the current, inductive current. So that's why it will lie somewhere around here. This is the familiar diagram which you already know. Familiar diagram which you already know. And the voltage will be here. Vc. Okay, this will lag the current because capacitor current leads the voltage. So this is the voltage current equations. All these things are present over here. So Now what you need to do, so you have assumed your current to be the reference, right? So you assume current to be the reference, that is fine, that is totally fine, there is no problem with it. But they have given you this phase angle, right? If they have given you this phase angle, so this angle will be what? This angle, now you assume your current reference and you have drawn the phasor diagram, that is fine, you have drawn the phasor diagram, but this angle is given, right? So this is equals to what? This is equals to 10 angle 30, correct? If my sin omega t is reference, if this is equals to 10 angle 30, then what will be the angle of I? I am 90 angle upwards, so I angle or VR angle will be, magnitude is 15 angle subtracting 90, because from here I have to move in the clockwise direction. So if I am moving in the clockwise direction, I have to subtract 90, so it will be 15 angle minus 60. So you have assumed your own reference, you have drawn the phasor diagram, after that you write the angles, then what will be the angle of VC? VC angle will be equals to 16 angle, another 90 I have to subtract, right? Another 90 degrees I have to move in the clockwise direction, so it will be minus 150. Okay. So my Vs will be equals to VR, that is 15 minus 60 plus, so I will write the same equation only, that my Vs equals to VR plus VL plus VC. So VR is this, VL is how much? VL is 10 angle 30 and your VC is 16 angle minus 150. Like you will get back the same answer only, there will not be much of a difference because there is a 90 degree phase shift from these and this. So you will get the same, although in phasor, right? In phasor the angle will be different. Now the angle will be different, but your initial reference also was different. So your resultant will lie somewhere around here. I will not calculate, this is the homework for you. The resultant will lie somewhere around here, correct? So this will be my Vs basically. So Vs magnitude will be same only, it will come out as same only. I am not writing the theta, so it will be 16.156. Some value theta, you can calculate the theta, and ultimately this waveform you will get the same sinusoidal. You will get the same sinusoid. There will not be any difference. Okay. So yeah, that was about it, this lecture. So this is right homework for you. Please put in the comments below what angle theta you get, and ultimately what is the sinusoid. Is it the same sinusoid that you get previously, or is it something else? Okay. This was the measure 2, and the third last one was simply finding the Z equivalent. This is the last one. We have more questions. Huh? No, this is the last one only. So this one I don't think much difficult, but because I have talked about series connection, how impedance are equivalent in series connection, how impedance are equivalent in parallel connection. So it is a both series and parallel connection. So in this AC circuit, right, simply you don't have to do anything else, just replace your circuit with capacitive reactance and inductive reactance. So this circuit, omega is how much? Omega is 20. So if omega is 20, this will be what? 1 by 20 C. J 1 by 20 into C. C is 10 raised to power minus 3 millifarad. This is 100, this will remain 100. This does not depend on frequency. This will be J omega L, so 20 into 8, and this will be 200. So ultimately your circuit, right, reduces to this much. So your circuit, these two are in series, correct? So I can reduce these two things. If these two are in series, this will be overall a impedance whose value is this is 10 divided by 20, so 2 divided by 50. So it is 100 minus J50. Okay, 100 minus J50. Here I have another impedance which is capacitive, of course, Z2, which is, oh, this I did not calculate. This will be what? This will be 1 by J omega C. Omega is 20, same only, 10 raised to minus 3. So this will also be minus J50. Okay. J3 is a series connection of 200 plus omega L. So 20 into 8 is 160, right? So yeah, it is basically these two are in series, correct? So now I can further simplify. These two are in parallel, these two are in parallel. So what I can do is, this is what, like parallel connection, this J23 will be basically J2 into J3 divided by J2 plus J3. I hope you know the parallel connection formula. So this will be minus J50 into 200 plus J160 divided by 200 plus J160 plus minus J50. So ultimately this comes out, if I divide by 10 on both sides, this will be J5 into 20, this will into 200 plus J160 divided by 20 minus 5, so this will be plus J11. Okay, so under root. Okay, so everything, let's convert everything into their phasor formats, polar formats basically. So this will be 22.825, angle will be what, 11 divided by 20, tan inverse 28.8 degrees. This will be minus j only, basically this will be 5 angle of minus 90, and this will be 200 square plus 160 square whole under root into 256.125 angle. This will be 160 divided by 200, tan inverse 38.66 degrees. So this value will come out to be, I'll just quickly calculate this value. So 256.125 divided by 22.825 into 5. So this is 56 something, 56 point something, okay, 10, 56.10, and what is the angle, right, will be 38.66 minus 28.82 minus 90, so it is minus 80. But this is not your answer, obviously this is not your answer, because this is just the this portion, right, this much equivalent. Of course I have to add, this is also this will also will come in series. So ultimately your circuit gets reduced to this, Z1 is here and I have another impedance named Z23 here. So this is your Zn, correct? So now I will add these two quantities. So it's better if I'm adding, I have to convert again in rectangular format. So this will be cos into 56.10. So this will come out to be 9.587 and 80.16 sine minus j into 56.10, 55.27 ohms. Okay, so your Zn ultimately, is Z1. What is Z1? Z1 was, if you remember, Z1 was this value, right? 100 plus 100 minus J50, 100 minus J50. So 100 minus J50 plus 9.587 minus J55.27. So minus 50 minus J 105 0.274. Okay, so now like if you want to convert it back into your polar format, so you can convert obviously into polar format. This will be square plus 109.587 whole square whole under root 151.96 angle will be, this is lying in which quadrant? This is lying in the fourth quadrant, so angle will be simply negative. So 105.274 divided by 109.587 tan inverse. So this will be minus 43.85 degrees. So this will be your answer basically. If in rectangular you write this, if in polar you write this. Okay, so that's it basically for this lecture, and in next lecture we will be covering the parallel RLC circuits, phasor diagram for parallel RLC circuits. So I hope you enjoyed this lecture. If you did, make sure to hit the like button, comment down below how, like what part you enjoyed the most. Of course, I will meet you in the next lecture. Until then, happy learning.